Hello, welcome to our classes. I am Dr. K. Misra. I have already uploaded a number of video tutorials on linear programming problems, CPM PERT, and the other different topics on operations research. Today I am taking up game theory, that is another important chapter in operations research. As we know that market is always facing some level of competition. Every type of market either has is perfectly competitive or imperfectly competitive. In every field in the market, there is some company, some player who operates at number one position. There may be some number two positions and third and the like. Irrespective of the position in the market, competitive market, there is always a fight, between the two parties. That fight may be between the two parties. Finally, it is between the two parties. Now, those parties may be an individual or an individual organizations, associations of different organizations. They may be fighting for their part in the market. Now, what strategy, marketing strategy, one party is adopting is not known to the other party. But at the same time, after all, everybody has to be ensuring that the parties must make some profit out of it. So, what strategy? What should be the best blend of the strategies the parties should adopt so that everybody almost is in a win-win situation? Actually, this is the problem that we can solve with the concepts and methods available in game theory. The topics which I will be covering here, that is, what is game theory, terms used in game theory, assumptions to game theory, types of strategies, whether pure or and mixed, 2% zero sum game, saddle point, 2 cross n and m cross 2 arrangement, and dominance rule. Game theory. Game theory is a body of knowledge which is concerned with study of decision making in situations where two or more rational opponents are involved under conditions of competition and conflicting interests. It deals with human processes in which an individual decision making unit, who can be an individual, as I spoke earlier, or a group, or a formal or informal organization, or even a society as a whole, is not in complete control of the other decision making units, obviously, the opponents I am talking about, and is addressed to the problems involving conflict, cooperation, or both at various levels. The branch of it is another statement we can have in order to understand the concept of game theory. It is basically the branch of mathematics concerned with the analysis of strategies for dealing with competitive situations where the outcome of a participant's choice of action depends critically on the actions of other participants. Game theory has been applied to context in war, business, and biology. The main objective in the theory of games is to determine the rules of rational behavior in the game situations in which outcomes are dependent on the actions of the interdependent players. A game refers to a situation in which two or more players are competing. It involves the players, basically the decision makers, obviously, who have different goals or objectives and whose fates are intertwined. They are in a situation in which there may be a number of possible outcomes with different values to them. Labor unions striking against the company management, players in a class game, army generals engaged in fighting the enemy, firms striving for larger share of market, and a duopolistic market conditions and so on, all illustrate situations which can be viewed as games. Now I'll talk about the different terms which we would be using and coming across whilst approaching the problems related to game theory. Here, number of players. How many players are there? This is important. If a game involves only two players, that is competitors, then it is called a two-person game. However, if the number of players is more, the game is referred to as n-person game. Strategies. The strategy for a player is the list of all possible actions, means moves or courses of actions that he will take for every payoff, that is outcome, that might arise. It is assumed that the rules governing the choices are known in advance to the players. Payoffs are the consequences for each player for every possible profile of a strategy choices for all players. Zero sum or constant sum game. One player's winnings are the other's losses, so the net is zero across all players. Optimal strategy. The particular strategy by which a player optimizes his gains or losses without knowing the competitor's strategies. Value of the game. The expected outcome per play when players follow their optimal strategy. These were the terms. Now we'll talk about the assumptions of the game theory. Here, each player has available to him a finite number of possible strategies, again, courses of actions. The list may not be same for each player. Player A attempts to maximize gains and B to minimize losses. The decision of both players are made individually prior to the play with no communication between them. The decisions are made simultaneously and also announced simultaneously so that neither player has an advantage resulting from direct knowledge of the other player's decision. Both the players know not only possible payoffs to themselves but also of each other. By convention, the payoff table for the player whose strategies are represented by rows, say player A, is constructed resultantly A attempts to maximize gains and B to minimize losses. In a game situation, each of the players has a set of strategies available. A strategy refers to the action to be taken by a player in various contingencies in playing a game, as defined earlier. The models. There are several game theory models which can be classified on the basis of factors like the number of players involved, the sum of gains or losses, and the number of strategies employed in the game. In a game situation, interests of two or more than two participants may be in conflict. The former of these is called a two-person game, and the latter one is known as n-person game. But it does not necessarily imply that in its play exactly n people would be involved, but rather that the participants can be classified into n mutually categories and members of each of the categories have identical interests. Now we'll talk about the strategies. Pure strategy. It is the decision rule which is always used by the player to select a particular strategy. Thus, each player knows in advance of all strategies out of which he plays, selects only one particular strategy, regardless of the other player's strategy. And the objective of the player is to maximize profit or minimize losses. Two-person zero-sum game. Again, here it is being talked about in more broader sense. A two-person zero-sum game is the one which involves two persons, players, and where the gain made by one equals to the loss incurred by the other. For example, suppose that there are two firms A and V in an area in which, for a long period in the past, have been selling a competing product and are now engaged in a struggle for a larger share of the market. Now, with total market of a given size, any share of the market gained by one firm must be lost by the other. The sum of the gain and losses equals zero. Mixed strategy. Courses of actions are to be selected on a particular occasion with some fixed probability are called mixed strategies. Let me tell you that mixed strategy case, you know, comes out when the pure strategy is not applicable, means when there is ambiguity that party A will adopt. If party A has clearly got a particular strategy to be adopted, and upon A adopting that strategy, if B adopts the same one strategy, that is pure strategy. But if there is ambiguity that no clear strategy is available, rather there could be a combination of two strategies for A. So upon A adopting two strategy, what other two strategies we may adopt? If this being the situation, then we say that here mixed strategy is applicable. Now, detail of pure strategy. We work here on maximin or minimax principle. Maximin criterion, the player who is maximizing his outcome or payoff finds out his minimum gains from each strategy and selects maximum value of these minimum gains. Minimax criterion, in this criterion the minimizing player determines the maximum loss from each strategy and then selects with minimum loss out of the maximum loss list. Saddle point or equilibrium point. In a payoff matrix, the value which is the smallest in its row and the largest in the column is called saddle point. A point to note here, it is possible that there is no saddle point of a game and so it is not possible to find its solution in terms of the pure strategies. Games without saddle points are not strictly determined. The solution to such problems calls for employing mixed strategies discussed in succeeding slides. Now, mixed strategy. As stated above in the note, that we use mixed strategy in case where no saddle point exists. A method of playing a matrix game in which the player attaches a probability weight to each of the possible options. The probability weights being non-negative numbers whose sum is unity and then operates a chance device that chooses among the options with probabilities equal to the corresponding weights. In a mixed strategy, the matrix is reduced to a 2 cross 2 matrix irrespective of its type. M cross n we apply dominance rule or M cross 2 and 2 cross n we solve it by graphical method. Now 2 cross 2 matrix. If P of matrix for player A is given by here in this matrix for player A, the two strategies A1 and A2 and B1 and B2 and their payoffs are like A11, A12, A21, A22. Suppose that A plays strategy A1 with probability X and plays strategy A2 with probability 1 minus X. And in the same fashion, B plays strategy B1 with probability Y and B2 with probability 1 minus Y. And let V be the value of the game. Then the following formulae are used to find the value of the game and optimal strategies. X is equal to A22 minus A21 upon A11 plus A22 within one bracket minus A12 plus A21 within another bracket. Y is equal to A22 minus A12 upon A11 plus A22 within one bracket minus A12 plus A21 within another bracket. And now the value of the game, that is A11 into A22 minus A12 into A21 upon A11 plus A22 within one bracket minus A12 plus A21 within another bracket. Dominance method. Rule 1. If all the elements in a row, say the ith row, of a payoff matrix are less than or equal to the corresponding elements of the other row, say jth row, then the player A will never choose the ith strategy, or in the other words, the ith strategy is dominated by the jth strategy. Rule 2. If all the elements in a column, say rth column of a payoff matrix are greater than or equal to the corresponding elements of the other column, say asset column, then the player B will never choose the RF strategy, or in other words, the RF strategy is dominated by the asset strategy. Number 3, a pure strategy may be dominated if it is inferior to average of two or more other pure strategies. Graphical method m cross 2 or 2 cross n. Now we consider the solution of the games where either of the players has only two strategies available. The player A, for example, has only two strategies to choose from, and player B has n the same game shall be of the order 2 cross n. Whereas in the case of B has only two strategies available to him and A has m strategies, the game shall be m cross 2. The problem may originally be a 2 cross n or m cross 2 game, or problem might have been reduced to such size after applying the dominance rule. In either case, we can use graphical method to solve the problem. By using the graphical approach, it is aimed to reduce a game to the order of 2 cross 2 by identifying and eliminating the dominated strategies and then solve it by the analytical method used for solving such games. The resultant solution is also the solution to the original problem, although the game value and optimal strategies can be read off from the graph. We generally adopt the analytical method for 2 cross 2 games to get the answer. Now we have here a semantic presentation of the method what discussed earlier. The moment a question comes across here in nutshell, conclusive, in this figure it is given. First start, write the payoff matrix. Is there pure strategy solution? Yes, obtain the solution. No. Is it a 2 cross 2 game? If yes, solve by using the analytical formula of mixed strategy. If no, use dominance rule to reduce the matrix as far as possible. Is this reduced to a 2 cross 2 game? If yes, again solve it by analytical formula of mixed strategy. If no, then alternatively formulate and solve by linear programming. Otherwise, again if it is no, then this is this a 2 cross n or m cross 2? If yes, use graphical method to reduce the problem to a 2 cross 2 game and formulate. If it is no, then formulate and solve as a linear programming problem. So that's how this was the conceptual, you know, detailed introduction, conceptually detailed introduction of game theory, methods and procedure. For any queries, you can write to ourclasses@gmail.com. More video tutorials on quantitative techniques and operations research are available on my YouTube channel given below our classes. Thank you. Please like, share and subscribe. Thank you very much. Have a nice time.